This is Varsha's Education Academy. In this session, we are going to see some problems in signals in system. This is a very important subject for all competitive exams. As you all aware of this subject, is mainly consist of different types of signals and its transformations, right? First, let us see the types of, that is classification of signals. There were 6 major classification in the signals. One is continuous and discrete time signal. Second one is deterministic and non-deterministic signal. Third one is even and odd signal. Fourth one is energy and power signal. Fifth, periodic and aperiodic signal. Sixth, real and imaginary signal. See, first let us see the concepts of all these types of signals. Let's go for the problem. Later on we will go for the problem, right? First type is continuous and discrete time signal. As you all know, continuous is nothing but a continuous form of signal. Discrete may be with some discreted samples of a signal, right? So continuous signal, see this example, this is a continuous signal. There is no any hurdles over there, right? This is a continuous form of signal. This is our amplitude x of t and this is a time axis, that is x axis, which is represented as time. This is our amplitude A and the signal is a continuous time signal. See, this is our discrete time signal. See the difference between these two types of signal. Here we are having only time samples. At those time samples we can find the amplitude, right? If we want to find the amplitude at any instant of time, that is possible only in this continuous time signal. But if we want the time in between these two samples, if we want to find the amplitude in between these two samples, it is not possible in this kind of signal, that is discrete time signal. See, have you all understood the difference between these two types of signal? See, in continuous time signal, we can find the amplitude at any instant time. We can find the amplitude at any instant of time. But in discrete time signal, if we want to find the amplitude in between any two samples, it is not possible. So this is the difference between continuous time and discrete time signal. Right? This is our first type. Have you all understood this continuous and discrete time signal? Okay. Let's go for second type, deterministic and non-deterministic signal. Second type of signal, deterministic signal. Deterministic and non-deterministic. See, deterministic is nothing but the signal can be determined in the mathematical form. Signal can be determined in the mathematical form. See, determined in the mathematical form is nothing but, let us assume one signal, that is x of t is equal to sin t. Likewise, any mathematical representation can be formed in deterministic signal. See, any type of signal that can be represented in this kind of mathematical transformation, in this kind of mathematical form. If a signal is determined using any mathematical form, then it is said to be a deterministic signal. If a signal that cannot be determined in the mathematical form, then it is said to be non-deterministic or random signal. See, this is the example of non-deterministic signal or random signal. This kind of signal does not form any single motion of a signal, single transmission. See here, there were different kinds of oscillations in the signal, right? So this is said to be the non-deterministic. We cannot determine the type of the signal. We cannot represent the signal in any mathematical representation or any mathematical form. So this kind of signal is said to be non-deterministic or random signal. If a signal that can be determined in the mathematical form is said to be deterministic signal. If a signal that cannot be determined in any mathematical form, in any mathematical representation, then those signal is said to be non-deterministic or random signal. Non-deterministic or random signal. Let's go for the third type of signal, that is even and odd signal. If a signal is said to be an even signal, then the x of t is equal to x of minus t. What is the difference between x of t and x of minus t? So x of minus t is the mirror image of mirror image or mirror reflection of x of t. Have you all understood? See, x of minus t is nothing but the mirror image or mirror reflection of x of t. So this is the difference between these two types, x of t and x of minus t. See, if these two real signal and its reflected signal are equal, then the signal is said to be even signal. See here, x of t is our real signal, x of minus t is our reflected signal. See, let us assume one signal over here. Let us assume one signal over here. I'll assuming one triangular signal. This is x of t. See, its x of minus t will be in this direction, that is reflection over y axis. This is our y axis and this signal gets reflected over this side. So this is the x of minus t. If x of t is equal to x of minus t, then the signal is said to be even signal. If x of t is equal to minus x of minus t, then it is an odd type of signal. So this is the difference between these two types of signal. If a given signal is an even signal, then x of t is equal to x of minus t. If a given signal is an odd signal, then x of t is equal to minus x of minus t. Right? Let's go for the fourth type of signal, that is energy and power signal. See, in energy and power signal, it is very simple. An energy signal cannot be a power signal and a power signal cannot be an energy signal. Right? A signal can be of any one type, whether it is an energy signal or it may be a power signal. Right? These 2 points are very important for any kind of competitive examinations of ECE department. You should remember these 2 points. These 2 points are very important even when compared to the problems in this type of signal. Mostly they want to ask energy and power signal type of formulas, problems. But these 2 points they will ask surely. So power of energy signal is 0 and the energy of power signal is infinity. See, power of energy signal is 0 and the energy of power signal is infinity. You should remember these 2 points. Then our fifth type of signal is periodic and aperiodic signal. See, from the name of the type of the signal itself, we can find it may be a fixed period of time. If a signal is repeated by the fixed period of time, then the type of signal is said to be periodic signal. If the period is not in the constant, if the period of a signal is not fixed, then the type of signal is said to be aperiodic signal. Have you all understood between the two? So periodic and aperiodic type of signal. Periodic signal is signal gets repeated in the fixed period of time. But aperiodic signal, it will vary with time. It won't have any fixed period of time, right? Let's go for the next type of signal, that is real and imaginary signal. Real and imaginary signal. See, this is the example for real signal. Real signal is nothing but x of t is equal to a. See, this a is maybe a constant or any fixed value or any integer. If this is a representation of any signal, then the signal is said to be a real signal. If it is an imaginary signal, then the signal representation will have any imaginary term. So a plus jb is the representation of imaginary signal. See, I have selected 2 constant terms, 2 variables, just to explain you. But any kind of signal with imaginary term I or j, then the signal is said to be imaginary signal. Right? Let's go for the examples of even and odd component. See, this is a very important topic in signals and systems. In competitive examination, surely they will ask this kind of problem. Right? This kind of problems in any competitive exam. See the problem. Find the even and odd component of a signal. See, this is our given signal. See, this is our given signal and the signal is represented by the term x of t and its amplitude is a and time period is 0 to 2. Right? See, we are going to find the even and odd component. First, you should remember this formula. That is x e of t is our even component of the signal. X O of t is the odd component of the signal. So even component of the signal is equal to x of t plus x of minus t by 2. So real signal plus the reflection of this real signal divided by 2. So x of t plus x of minus t by 2. See, if it is an odd component, if we are going to find the odd component of a signal, so the real signal gets subtracted with the reflected term. Right? X of minus t is the reflected form of the real signal. So the real signal gets subtracted with the reflected form and it is divisible by 2. Is said to be odd component of the signal. Let's go for the solution. First we are going to find the x of minus t. Right? If we have find out the x of minus t, then we can add these two types of signal, x of t and x of minus t. See, this is our x of t signal. This is our x of minus t signal. Just I have taken the mirror image over this y-axis. Just I have taken the mirror image over this y-axis. Have you all understood? So 0 to 2 we are having signal over there. Here in x of minus t we are having 0 to minus 2. The same amplitude A. Right? So this is our x of minus t. This is our x of t. Now what is our even component of the signal? We need to add these two types of signal. We need to add these two type of the signal. So I have just added these two type of signal. Minus 2 to 2, the same type of signal with the amplitude A. Right? I have just added these two signals in this term. X of t plus x of minus t. Right? X of t plus x of minus t gets added in this signal. See, what is the difference between this one and this one? This is our even component of the signal, that is x e of t. So x e of t is equal to x of t plus x of minus t divisible by 2. So how this by 2 will come? This amplitude get divisible by 2. See here, the amplitude will be a by 2. Remaining time period and all same, but only the amplitude gets divisible by 2. Right? Only the amplitude gets divisible by 2. So the amplitude of this even component signal is a by 2. Time period will be minus 2 to 2. So this is our even component of a signal. This is our even component of a signal. Right? Let's go for the odd component. Have you all understood up to this step? If you are having doubts, do comment in the comment box. Let's go for the odd component of the signal. See, first we will see the x of minus t. X of minus t signal. How it will be? This is our x of minus t, right? So this is our x of t and this is our x of minus t. This line won't come. Now in odd component we are having minus x of minus t. So we have to find minus x of minus t. For that first I have drawn x of minus t. It is just a reflection of the given signal. So I have drawn this x of minus t. See, if it is in the minus x of minus t means this should be in the negative axis, negative y axis, right? See the difference between these two things. This is x of minus t, this is minus x of minus t. This signal gets represented in the negative y axis, that is said to be minus x of minus t. Right? Now we are going to subtract, or we are going to add x of t minus x of minus t signals. So this is the representation of x of t minus x of minus t. So what is the difference between this one and our odd component? Divided by 2 is missing, right? See here, we are finding the divided by 2 signal. See, what is the difference between x of t minus x of minus t and XO of t, only difference is the amplitude becomes halved, right? See here also I have reduced the amplitude to a by 2. So a by 2 minus a by 2, 2 minus 2 to 2 is our time period, but the amplitude is varying a by 2 to minus a by 2. See, this is our even component of the signal, this is our odd component of the signal. So these two are the final answer what they are asking, right? If we want to add these two signals, what will happen? We will get our original signal in the question, what they have given in the question. How we are getting? See, if we are adding these two signals, see the amplitude from 0 to 2 is a by 2. See the amplitude from 0 to 2 is a by 2. So these two signals get added together and we are getting the amplitude as a. But see here, from 0 to minus 2 it is minus a by 2. From 0 to minus 2 it is a by 2. So minus a by 2 and plus a by 2 get cancelled. So our final signal will be like this. See, only from 0 to 2, only from 0 to 2 it get added. But from 0 to minus 2, here we are having minus a by 2, here we are having plus a by 2. So these two get cancel each other and our final signal will be this one. From 0 to 2, x of t is a. So this is our original signal what they have given in the question. How we are getting? By adding odd component and even component of the signal, we are getting our original signal what they have given in the question, right? If you want to check your answer, you can do like this method, right? See, this is the second example for even and odd component of the signal. The same question from the as a last example, find the even and odd component of the given signal. See here the signal is varies from 0 to 2. Time limit is 0 to 2 and x of t is amplitude is 4, right? So amplitude of this x of t signal is 4. First step we have to find the reflected form of the signal. First step we have to find the reflected form of the signal, that is represented as x of minus t. See here 0 to 2 amplitude 4. Again 0 to minus 2 amplitude 4. So this is the mirror image of the given signal x of t, right? Our next step is we have to add. See, this is our even part, this is our odd part. See, once again I am explaining you, this part is to find the even component, this part is to find the odd component. So x of t plus x of minus t. So x of t is our given signal and x of minus t is our found out signal, that is mirror image of the original signal. So now I have added these two signals in the step. So 0 minus 2 to 2 amplitude 4 with a triangular signal, right? So this is our x of t plus x of minus t. So what is the even component formula? Divided by 2. X of t plus x of minus t divided by 2, right? So I have just divided this amplitude alone divided by 2. So amplitude will be 2, but the time limit will be minus 2 to 2 with the triangular signal amplitude 2, right? So this is our even component of a signal. Have you all understood this type? This is our even component of the signal. Next, odd component. For odd component we have to find minus x of minus t. So minus x of minus t in the sense we just make this component in the negative y-axis, right? That is nothing but the minus x of minus t. So this is negative y-axis, 0 to minus 2, amplitude of minus 4, right? Minus x of minus t is nothing but the amplitude should be in the negative. So I have selected this negative y-axis, right? So x of t minus x of minus t is nothing but we have to add these two signals. We have to add these two signals. So I have just added over these two signals and this is x of t minus x of minus t. Minus 2 to 0 we are having the negative amplitude of minus 4. From 0 to 2 we are having the positive amplitude of plus 4. So this is our x of t minus x of minus t. So final odd component will be this amplitude divided by 2. That is the formula, right? So xo of t is equal to x of t minus x of minus t divided by 2. So I have just divided the amplitude alone divided by 2. So 4 by 2 is 2. So minus 2 to 0, the amplitude will be minus 2. From 0 to 2, the amplitude will be plus 2. So this is our odd component of the signal. This is our even component of the signal. Now let us add these two types of signal to get our original signal what they have given in the question, right? We will prove for this problem also, right? If we are adding these two parts, see here we are having plus 2. But at this end we are having minus 2. So plus 2 and minus 2 get cancelled each other. From 0 to 2 we are having the amplitude 2. From 0 to 2 we are having the amplitude of 2. So 2 plus 2, 4. So that is our original signal. From 0 to 2 with amplitude 4 of a triangle signal is said to be our original signal. What they have given in the question as x of t, right? So if you are having doubts, do comment in the comment box. This session is very important session of a signals and systems, right? So please make a note of it, and this kind of problem, surely any one problem they will ask in TRB as well as TNEB AE, right? So please refer this before going for the exam. Even and odd component of a signal, and you should remember that this one is very important. So do remember these two formulas. Xe of t is equal to x of t plus x of minus t by 2. Xo of t is equal to x of t minus x of minus t by 2. So these two formulas are very important in solving even and odd component of a signal. So in order to find the even and odd component of this signal, we should know this formula, right? Then only we can add or we can subtract from our original signal. First we have to find the reflected signal or mirror image of the given signal. Then second step will be we have to add if we want even signal. We have to subtract if we want odd signal, right? Then what is our next step? We have to divide our amplitude by 2. We have to divide our amplitude by 2. That is our even signal, even component and odd component of a signal. That is our even and odd component of a signal. So please remember this formula. Thank you all. Thank you for watching this video. If you are having doubts, do comment in the comment box.